Science for life. Do you want to know more about the world around you? Then subscribe, like, and let's get started. How computers work, a comprehensive guide to understanding the inner workings of modern technology. In today's digital age, computers are an integral part of our daily lives, revolutionizing the way we work, communicate, and access information. From smartphones to laptops, desktops to supercomputers, these powerful machines have become essential tools for individuals, businesses, and industries worldwide. But have you ever wondered how computers work, and what makes them capable of performing complex tasks? In this comprehensive guide, we will take a deep dive into the inner workings of computers, demystifying their functionalities and shedding light on the fascinating world of modern technology. 1. Introduction to computers. Computers are electronic devices designed to receive, process, and output data, making them versatile tools for various applications. At the core of every computer is a central processing unit, CPU, often referred to as the brain of the computer. The CPU is responsible for executing instructions and performing calculations, enabling the computer to process information and perform tasks. 2. The basics of binary. At the heart of all digital computing lies the binary system, which uses only two digits, 0 and 1, to represent information. These binary digits, known as bits, are the building blocks of computer data. A collection of 8 bits forms a byte, the basic unit of data storage in computers. Through combinations of zeros and ones, computers can represent text, images, sounds, and other types of data. 3. Hardware components. To understand how computers work, it's essential to explore their hardware components. These include motherboard, the main circuit board that connects all other components and provides a pathway for communication between them. CPU, central processing unit. As mentioned earlier, the CPU is the brain of the computer, responsible for executing instructions and performing calculations. RAM, random access memory, a temporary storage space where the computer stores data that it is currently using. RAM allows for quick access to data, which enhances the computer's performance. Hard drive, HDD, or solid-state drive, SSD, the storage devices where the computer permanently stores data, including the operating system, programs, and files. Graphics processing unit, GPU, dedicated hardware designed to handle graphics-related tasks, essential for gaming, video editing, and other graphic-intensive applications. 4. The operating system. The operating system, OS, serves as the intermediary between the user and the computer's hardware. It manages the computer's resources, allocates memory, schedules tasks, and provides an interface for users to interact with the machine. Common examples of operating systems include Windows, macOS, Linux, and Android. 5. The software. Software refers to the programs and applications that run on a computer. These can range from productivity tools like word processors and spreadsheets to entertainment software like video games and media players. Software is created using programming languages, and when executed, it provides specific instructions to the computer. 6. The boot process. When you power on a computer, it goes through a series of steps known as the boot process. During this process, the computer's hardware initializes, the operating system is loaded into memory, and essential system components are initialized to prepare the computer for use. 7. Input and output devices. Computers rely on input and output devices to interact with the outside world. Common input devices include keyboards, mice, touchscreens, and microphones, allowing users to input data and commands. Output devices, on the other hand, include monitors, speakers, and printers, enabling the computer to present information to users. 8. The fetch-decode-execute cycle. The central processing unit follows a fundamental process known as the fetch-decode-execute cycle to carry out instructions. In this cycle, the CPU fetches instructions from memory, decodes them to understand what action is required, and then executes the instructions by performing the necessary calculations or operations. 9. Machine language and assembly language. Machine language is the lowest level of programming language, consisting of binary instructions that the computer's CPU can directly execute. Assembly language is a higher-level representation of machine language, using mnemonics to represent specific instructions. Programmers use these languages to write software and communicate directly with the computer's hardware. 10. Binary arithmetic. Computers can perform various arithmetic operations using binary numbers. These operations include addition, subtraction, multiplication, and division. By representing numbers in binary form, the computer can manipulate data efficiently and accurately. 11. Programming languages. To make computers perform specific tasks, programmers use high-level programming languages like Python, Java, C++, and more. These languages allow developers to write code using English-like commands, making it easier to create complex software. 12. Computer networks. Modern computers are often interconnected through computer networks, allowing them to share data and resources. Networks enable communication between computers, providing a way to access the internet, share files, and communicate with other users around the world. 13. The Internet. The Internet, a vast global network of interconnected computers, has transformed the way we access and share information. Through web browsers, users can access websites, connect with others through social media, and communicate via email. 14. Cloud computing. Cloud computing allows users to store and access data and applications over the internet, rather than on local computers. This technology provides flexibility, scalability, and convenience, allowing users to access their data from any device with an internet connection. 15. Artificial intelligence and machine learning. Advancements in computing have led to the emergence of artificial intelligence, AI, and machine learning. These technologies enable computers to learn from data, recognize patterns, and make decisions, leading to advancements in fields like robotics, natural language processing, and autonomous vehicles. 16. Quantum computing. Quantum computing is an exciting area of research that explores the use of quantum mechanical phenomena to perform computations. These computers have the potential to solve complex problems exponentially faster than traditional computers, revolutionizing fields like cryptography and drug discovery. Conclusion. Understanding how computers work is essential in today's tech-driven world. From the basics of binary to the complexities of quantum computing, the inner workings of these machines continue to shape our lives and drive technological advancements. As we continue to explore the boundaries of computing, the future holds even more exciting possibilities, propelling humanity into new frontiers of innovation and discovery. Thanks for watching. Subscribe so you don't miss our next videos.